Okay, by the way, class, this is the part 2 of our lessons about leveling. So last time I forgot to discuss about the instrument used in conducting leveling, no? So these are the most common instruments. So this is the Y level. Mostly ito yung pinaka karaan or old. So muna ang iyang level bar. As you can see then, this is the telescope. Then this part is gina-clamp ra na siya sa ano, sa tripod, no? And then this is the most modern, the dumpy level. Muna siya pinaka-common na ginagamit karon as the moment sa mga leveling surveys, no, sa pag-level. So this is the tripod. So naa siya mga bubble tube diha, muna ang gina-slit para ma-balance, no, para horizontal and level jud ang ano, ang instrument. Okay, so kini pwede siya matuyok maski asa at 360 degrees. Then i-clamp nimo siya para malak. Okay? So una siya. Bali, by the way, nagkontak ko pre-recorded video kay by next Wednesday is na may meeting sa ano, SES program basta dili ta makapag-meet. So nag-record na lang ko daan. Okay, so let's proceed. So next meet for today it's about another method of leveling is the three-wire leveling. So in three-wire leveling, so gamit kag telescope, based sa telescope, you can see three readings. So the top, the bottom, and the center. So three-wire leveling consists of making rod readings on the upper, middle, and lower crosshairs. So formerly, it was used mainly for precise work. So mas precise siya sa tanang mga leveling works. So we will discuss this in details when we go on to stadia or trigonometry surveys. So it has some advantage, no? It provides checks against rod readings, blunders, produce greater accuracy because of averages of three readings, and furnishing stadia measurements of sight lengths to assist in balancing back sights and foresight distances. Uh, the difference between the upper and lower readings multiplies by the instrument stadia interval factor gives the sight distance. So in leveling, the distance are often not important. Okay, so what is important is the sum of the plus sides. The BS is about equal to the sum of the minus sides, which eliminates errors due to curvature, refraction, and communication errors. So these are the formula that we need in dealing the three-wire leveling. So S stands for stadia intercept, or a reference between the upper stadia hair reading and the lower stadia. So okay, so we will discuss this in more details when we go on to lesson 9. So we will just skip this topic. So we have the example of telescope, mao ni ang crosshair niya, no? We have the upper reading and the lower reading, then the middle reading. So this is the A, B, and C. Okay. We have some examples, so let's skip that. So one of the most common or of leveling works is the profile leveling. So in this case, this is the process of determining differences in elevation along a fixed line at designated short measured intervals is known as profile leveling. So it is executed to provide data from which a vertical section of the ground surface can be plotted. So a profile is necessary for the design and construction of roads. Number one yun, syempre yung roads, railroads, canals, culverts, bridges, sewer lines, etc. So the fieldwork involved is identical to differential leveling, since also requires establishment of turning points in which foresight and backsight readings are taken before the terminal point is reached. Okay, so example, this is the benchmark. This is the first stations. No, so you have some station here. Okay, station 1, station 2, station 3, station 4, station 5, and so on until TP. TP2. So we have TP1. So nakuha di ang mga elevation, no? So during survey, so you will install your instrument in between para makuha nimo ang ilang mga readings, no, backside and the foresight. Then for computation, makompute nimo ang elevation of each stations. So given the elevation, computed elevations, you can come up with the profile or the cross sections profile of of the survey. So from there, makita ninyo, no, kung saan itsura sa cross sections. So napaka-importante siya sa kung ano, sa pag-design sa mga kalsada and other engineering structure, no. So it may be a single straight lines or a series of straight lines connected by surveys. So sa karamihan sa mga projects, no, engineering projects, yung ang profile is usually taken along the center line, lalo sa kalsada. Pero maintain siya mag-start sa center line. So with the level set up, the convenient distance away from it so that sites or more uniform lines can be obtained. So pwede na siya combination of double-radded and a check. So pag-check may be made by trying into previously established benchmark or by running a line of differential levels back to the starting point. So hindi ka nag-start hangtod makaabot ka sa TP2. So pag check daw niya, actual is magpadagan ka og differential level. So from TP2, since na establish naman nimo ang elevation ay na point, magpadagan na pud ka ay na point going to this point. Okay, so before we go, let's first define the terms na dapat ma-familiarize ninyo, no, with conducting a profile level. So letter A, profile. When we say profile, is a curved line which graphically portrays the intersection of a vertical plane with the surface of the earth. So it depicts ground's elevation of selected critical points along a surveyed line and the horizontal distances between these points. So this is the profile. It's a curve daw by definition. So muna siya ang ginatawag na profile. Okay, stationing is the numerical designation given in terms of horizontal distance. So any point along a profile line is always from the starting point. So each stake is used marked with its station and plus. So from here, sinakabutan ito. So wala, no. So example na siya every 10 meters ang iyang stationing. So let's say this station 00. Next station is station 00 plus 10, mga ganon. Then, another station, 00 plus 20. Ganon. And another station, 00 plus 30. Ganon. So, depende sa intervals ninyo. Kung every 5 meters, o malahi na po siya, by 5 na po. Or by 20. So, depende na sa intervals ang inyong stationing. Okay? Then, intermediate for sites. So these sites, also known as ground rod readings, are taken along the center line of the proposed projects to provide an accurate representation of the ground surface. Intermediate foresights observed at irregular intervals and at points where sudden changes in elevation occur. So example dire, no, mo na ang setup sa imong instrument. So from this station, nagbutang ka dirig mga lahi-lahi na na points or station. So from there, ginakuha nimo ang ilang kanya-kanyang foresights. So from point A to your location, so that is the backside still. Then from each station, nagatawag na intermediate foresights. Okay? Then turning point, syempre foresight na pod ka diha. Then bago ka mo transfer na pod og lahi na location. So kanang sightings nimo o readings nimo from your instrument going to each stations, manang ginagitawag na intermediate foresights. Okay, let's proceed. Then pull stations. So these are points which are established along the profile level route at uniformly measured distance. So ito yon. So kung by 100 ang interval, so mo ng 100, 00, so that is the starting point. Then 00 plus 100, 00 plus 200, mo na ang pull stations. Then kanang in between those pull stations is ginatawag na plus stations. So there are any other intermediate point established a profile level route which is not designated as pull station is called a plus station. So these points are taken at breaks in the ground surface, slope, and at critical points. So example diri daw critical points. So kung ang pull station nimo as at 00 plus 10 meters, so pwede ka diri mag plus point 00 plus 11.5 stations kay example na ay tawag ani na obstructions, no, or ang lahi ang iyang kuan diyang apart elevations maingon ana muna nagka na ay mga intermediate or plus stations. So these points are taken at break in the ground surface, slope, and critical points such as intended location of culverts, bridges, and other structures. So kini na mga structures kinahanglan pod makuha ang ilahang mga plus stations para when you plot it sa mapa, so makita pod gyapon ninyo siya sa profile. Okay? Then vertical exaggeration is the process of drawing the vertical scale for the profile much larger than the horizontal scale in order to accentuate the difference in elevation. So usually, di ba, pag mag-draw ka dire, usually nagamit ang scale, no? But when you are plotting the vertical or the elevation, so dapat daw exaggerate siya para at least mas maklaro ang iyahang profile. Amo na ginatawag na vertical exaggeration. Exaggerate, exaggerate kayo ang iyang pagka-drawing. So ana siya. Then we have profile paper. So special heavy grade wrapping paper used for plotting profiles. So the paper has horizontal and vertical lines drawn in green, blue, or orange, which are spaced accordingly to represent certain distances to the horizontal and vertical scale. So mao na ginagamit namo sa una, no. Dami mag-drawing og profile sa mga kalsada or sa mga cross section sa mga bukid o mountains. Sa una manual yun ang pagplot ana sa papel. Pero karon since na may AutoCAD, digitize na tanan. So mas dali na lang. So no need na to buy profile paper. Okay, so sa pag-arithmetic check sa profile, we have the elevation at BM2 is equal to elevation of BM1 plus summation of the backside minus summation of FS. So same lang gyapon sa differential leveling, no, sa pag-check niya kini na formula. Okay, we have, I think this is an example. So work out the following problems regarding points and stations along a profile level route. So a turning points along a profile level route measures 126.44 meters beyond station. Station 8 plus 0.24.5. So this is a plus or full stations. So this is an plus stations. So determine the stationing of this turning point. Letter B, determine the stationing of the previous turning point if it is instead located 83.45 meters before the given reference station. And letter C, determine the distance between station 33 plus 045.02 and station 26 plus 062.75. Okay, muna atong problem. Okay, so we have the problem here. So letter A, we have a turning point along top reverse measures 126 point beyond. So let's say this is the station 8 plus. Oh no. Line dot apply. Bilog na lang. So this is the station 8 plus 0 to 4. So this is a plus stations. Then from that point na ITP, turning point, with a distance of 126.44. Okay, the measurement is 126.44 meters. So sa mga stationing, pag makita niya yung ane is by meters niya. No, so this is in hundreds. So kung yung ana, so 8 plus 24.5, so mahimo siyang 824.5 distance. So the distance at the station is 824.5 meters. Okay, so now is the total distance. So the distance from 8 plus 24.5 stations to TP is equals to, so 824.5 plus 126.44, 824.5, that is equals to 950.94. meters. So mo na ang iyang distance, no, from the starting point. But the question is determine the stationing of this turning point. So therefore, we conclude that the stationing or the stations at this point from 0 point is from here. So that is 9 plus, wait lang. So that is station 9 plus 50.94. Parang mali ko dili sa 8 plus 24.5. So dapat wala din itong 0. Okay, so kindly disregard the 0 sa problem, no? Mali ko kopya. Okay, so the answer for letter A is 9 plus 50.94. So mauna ang station at turning point. Okay. Next problem, letter B. So determine the stationing of the previous turning point if it is instead located at 83.45 meters before the given reference. So kung example daw, diya atong previous location, no, if it's located at 83.45 meters before the given reference station. So this is the given reference station. So before daw dire na side. So 824.5. So kung diri siya, diri ang station 8 plus 24.5. So imbis na diha daw ang TP, na diri na side. So that is pila to 83.45 meters. Ooh, hindi naman kuan. Oh, yun. I need to buy a ano, pen tab talaga para mas dali magsulat. Okay. So that distance is 100 ito nakabutang 83.45. So ang tawag is stationing, no? So this station. So 824.5 minus 83.45. So that is 741.5. So the stationing would be 7 plus 41.05. Okay. So this is the stations of the turning point. Okay, for letter C, determine the distance between station 33 plus 045.02 and station 26 plus 062.75. Okay, so ikuha ko lang natin ang ilahang mga distances, no? 33 plus 45.02. So this is station. So by 100, pwede po siya na ay 0. Then ang isa is station 26. So na-interchange na ako. So let's assume na lang na going to the left ang direction sa atohang stations, no? So baliktad lang. So dito nag-start imbis na sa left. 26 plus 062.75 stations. So the measured distance or the distance from the reference station of 00. So this is 33 plus 45.02 meters. So 3,000. This stations 26 62.75 meters. So therefore, para makuha nato ang the distance between these two stations, we'll just subtract. Okay, so the distance would be 3345.02 less 2662.75. That is equals to 682.27 meters. Okay. So any questions so far? Okay, let's proceed. So these are the given. So given ang mga backside and the intermediate foresight and the foresights of each stations. Okay, so from the formula from differential leveling, so we can compute for the HI. So that is 125.5 plus 0.95. That is equals to 126.45. Then for the elevations of the substation 0 plus 0, 0, 0. So that is equals to HI minus the intermediate foresights. So that is 123.45. So same true with 0 station 0 plus 0, 10. That's HI minus 2.3, the intermediate foresights. So that is 124.15. Okay, so for the elevation of TP1, so that is equals to 1 HI minus 0.64. Okay, that is 125.81. Okay, next is the HI of TP1. So isa lang gamiton diri na HI kay kini is murag aing manggod siya iyang profile, no. So we have, so example, this is benchmark 1. Then we have the TP1 turning point. So we have two stations. So we have 0 plus 0, 0. Sample diri ang instrument. So backside, foresight sa TP1. So na kay duha ka profile dire. That is station 0, 0 and station plus 10. So unang nakuha nimo ang ilang intermediate foresights. So that's a TP1, then balhin na pod ka dire sa other side. Nga na siya. Lahi na pod ka na setup. So pambiyag gikuha nimo ang iyang backside from TP1, una ang 3.13, then you get a 1, 2, 3, 4, 5. So 5 ka substation, that is 0 plus 22, 1, then 0 plus 0, 30.5, then another 0, 34.2, then another plus 0, 39.3, and 0 plus 42.5, then TP2. Na siya. Then so dire na kay foresight, then intermediate foresight for each substation. Ang naging ana ang nahitabo. Okay, then balhin na pud ka para makuha nimo ang TP3 and so on and so forth. Nga na siya. Okay, asa na ta sa HI. So HI sa TP1, so that is equals to the elevation TP1 plus the backside. So that is 128.94. So the elevation at plus station 0 plus 022 is equal to HI minus the intermediate foresight 126.124. So same sa substation. So HI minus 2.8. Then 100 HI minus 3.1 is equal to 126 less 0.5. Then that is equals to HI minus 0.8. So that is 128.14. Okay. Then TP2 elevation, that is equals to wait lang. That is equals to the HI 128.94 minus the foresight. Okay. So the elevation at plus station 0 plus 045 ay HI sa data. That is the elevation plus the backside at TP2. Okay. So the elevation at task station 0 plus 0.45 is equal to the HI less the intermediate foresight. So at task station 48.6, HI less the intermediate foresight of 1.2. Then next sub task station, HI or the height of instrument minus the intermediate foresight 1.7. Then at 0 plus 0.3.7 station, so HI minus 2.8. So same at TP3, the elevation is equals to HI minus 2.37. Okay, then the HI TP3 is equals to 137.45 plus the backside of 0.82. Okay, so the elevation at TP4 is equals to HI of 128.27 minus the foresight of FS 3.5, 124.77. Then HI is equals to 124.77 plus the backside of 1.35 at TP4. Okay. Then the elevation at 0 plus 0.75 station, that is equals to HI minus the intermediate foresight. Then for BMB, the elevation at BMB is equals to 126.12 minus 1.99. So that is the foresight. 124.13. So the elevation at benchmark B is 124.13 meters. Okay, let's conduct some arithmetic check. So summation at the backside. And summation at foresight. So basta foresight, negative ang iyang sign, no? So we have the elevation at 125.5. So that is dapat mag-equals sa elevation sa BM2. So let's add the backside minus the sum of the foresight. So equal sila. So from there, we can say na tama ang atong computation sa elevation for each stations. So that is the arithmetic checks. Okay, so far so good. So again, let's go back to the presentation. So siya. Okay, next, so we have these stations. Complete the following set of profile level notes and show the customary arithmetic check. So this will be your assignment. So we only have benchmark 3. Then it has a 1, 2, 3, 4 substations. Naka-full station siya. Then TP1. Then 1, 2, 3, 4 plus stations na pod. Then before the BM4. So you will compute the elevation at BM4. Then conduct also the customary arithmetic check. Okay. So let's proceed to another method of leveling. We have the rise and fall method of leveling. So the rise and fall method is based on the principle that two consecutive readings from the same instrument position gives the difference in elevation of 2 points sighted. So in this method, the actual height of the instrument has no real significance other than being the line to which vertical distances are conveniently measured from various points on the ground. So we will not just go into detail the rise and fall. So just go over na lang the notes. So wala man kayo siya gamit na, no, sa actual field, no. Then we also have the reciprocal leveling. Sometimes in leveling across topographic features such as rivers, lakes, and canyons, it is difficult or impossible to keep plus and minus sides short and equal. So reciprocal leveling may be utilized at such locations. So in this method of leveling, two sets of rod readings are observed. One set is taken with the instrument set up close to one point and another with the instrument set up close to the other point. Okay, let's check the setup. So this is the method of reversion just as employed in a two-peg test. So almost same siya sa ano, no, sa peg test, two-peg test. Ang iyahang methods or procedure. So yung ano lang siya, mag-set up lang ka near sa point A, then transfer na pud ka set up sa nearest setup sa point B. So murag yung ano lang siya na point. Reciprocal leveling example. So dili na po ta mag go into details ani. So this will only be part of your assignment na lang. So almost same lang siya sa two-peg test na discuss na to last meeting, no. Okay. Then trigonometric leveling. Trigonometric leveling or indirect leveling is defined as determination of differences in elevation from observed vertical angles in either horizontal or inclined distances. So the difference in elevation between 2 points can be determined by measuring the inclined or horizontal distance between them and the zenith angle or the altitude angle to one point from another. So yung ano siya. The vertical distance is equal to S sine alpha H tan alpha. So I think mapil gyapon ni siya in detail sa atong discussion sa next topic about stadya. So we will not proceed to the discussion of trigonometric leveling. So this method of determining difference in elevation should be limited only to horizontal distances not exceeding 300 meters. So when distances are much longer, the combined effects of Earth's curvature and refraction must be considered and applied in the calculation of vertical distances. Okay, so pang short distances lang siya. Pwede. So when trigonometric leveling is employed in much longer sites, the slope distance is measured using EDM instruments, and precise optical theodolites are utilized for measuring vertical angles. Also, the correction for the combined effects of curvature and refraction is added when the vertical angle is an upward side and subtracted when a downward side is observed. So, gi-add niya effect of the curvature and refraction. So, we'll just discuss na lang this sa next topic na to, no? Okay. Okay, let's proceed to adjustment of level circuit. So, when we say level circuit or loop is a line of levels which begins and ends at the same point or is run between points of precisely known elevations. In running a closed loop, it will always be expected that the observed elevations as computed from the level notes will not agree with the known elevations of previously established points within the loop. So the difference between the observed and known elevations of the initial point or benchmark is referred to as the error of closure. So sa leveling, no, asa ka nag-start, sample nag-start ka sa benchmark 1, then nag-end ka sa benchmark 2, so gi-compute nimo ang iyang elevations, then para mahimo siyang loop, balik na pud ka dito sa benchmark 1. So there are cases na when you close the loop, no, there will be an error of closure. So dili siya mag-close gihapon. So mali ang balik na computation nimo sa elevation at benchmark 1. Mao nang ginatawag na error of closure. Okay? So how will we adjust that error? So naa siya dire. So for letter A, levels over one root. So one root lang siya, no? Mura siya sa differential leveling lang. So when a line of levels closes back on the benchmark at the beginning of the survey, so the observed elevation of the initial benchmark will not be equal to its known or accepted elevation. So apparently, there will always be an error of closure. So to compute the error of closure, we have the formula EC, that is plus or minus elevation at observed minus elevation of known. Where is this? Error of closure, elevation observed, the observed elevation. Ito yung computed. Elevation known is the known elevation or given elevation. Then for the corrections, that is the ratio of the error of closure to the length or perimeter of the level circuit multiplied by the horizontal distance of the point from which the initial benchmark. Okay. So correction, this is the small letter D kining nasa horizontal distance. Okay. If the error of closure is a negative value, all computed elevations corrections are to be added to the corresponding observed elevations. So if positive naman, corrections are subtracted. Okay. So before to mag sa example, diri sa levels over different roots. So when the elevation of a benchmark, so daghan siya roots na gamit para ni sa mga double-rotted or sa profile leveling, no? So when the elevation of a benchmark is to be established by running several lines of levers over different routes from a common point of origin, it will always be certain that different results will be obtained. So in this manner of leveling, there will be as many observed elevations as there are lines terminating at the benchmark to be established. Okay. Levels over different example. Okay, so the example. Okay, proceed to sa example sa levels over one root example. So, mo ni ang given, no? Gitabilit na ako ang given. So, this is the observed elevations or the computed elevations. Then, the distance. So, kabalo na magkuha sa mga distance, di ba? Kining stations, mo naman siya ang iyang mga distance. So, these stations, 22 meters, 30.5. So, mo na siya. Okay? So, from this, so this is a circuit loop. So nag-end siya sa benchmark 1. So gipa kuan niya gihapon kuha siya nag-start, dito siya nag-end. So if you will notice, no, the known elevation, so this is the known elevation since mo nang pinakauna, is different from the observed elevation, that is 728.486. So the problem is you will determine the error of closure. So for letter A, sino nakabutang sa problem? Wait lang. Okay, letter A, determine the error of closure. So we know the formula. The error of closure is plus or minus elevation observed minus the elevation of known. So the error would be EC is equal to elevation observed observed minus the elevation known. So that is equals to this. So this is the observed or the computed minus the known elevation. That is equals to 0.244. So that is the error of closure. So for letter B, correction to be applied to each observed elevation sa atohang formula. So the correction is kuha sa nato ang total distance of benchmark 1 to wait lang 5.245 is another 30.5. So the corrections to be applied uh, correction 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 so itong nasa kuan that is core lang, core is equal to negative EC divided by D times each distance. Okay. So we have start EC is 0.244 divided by the total distance. So this is the total distance of 30.5. Para mas dali lang itong pag-check niya. 0.008. So that is the error of closure divided by the total distance. So the observe is multiplied by lang nato by each horizontal distance. So this is the horizontal distance from benchmark. So that is equals to 0.008 times distance 0.042. Please take note that this is a negative, so dapat this would give us a negative. Kasi atong formula that is negative side naman da ano, ay negative sign dire. So na ay correction, so dapat dire is mahimo na siyang positive. Okay? So CET in dollar sign. Okay, so these are the corrections to be applied to the observed elevations. So unsa tong giingon ganina, so how will we apply? So we have the negative error of closure. So what we need to do is negative. All computed elevation corrections are to be added to the corresponding observed elevations. So i-add daw. So the correct elevations correct elevation plus masyadong maraming ah, okay. Okay, so kaya ko din eh. So you can see the correct elevation is now equal to the observed elevation of 728.3. Okay. So mo na siya ang iyang applications. So letter C, adjusted elevation of the benchmarks along the level route. So mauni na siya ang letter C. Okay, so that's all muna for today. We'll just continue na lang next meeting. Okay. Bye-bye and see you next meeting.